Hello and welcome to the Modo 801 character rigging course. My name is Sergio Mucino and I'm going to be taking you through this journey. Yeah, that's cheesy, I know, but that's what it is. It's a very long, endless journey when it comes to rigging stuff and 3D applications. In this case, we're going to be doing specifically characters in Modo, and I'm going to show you how to use all the tools that we have available in the software to take a character from modeling asset all the way to finished rigging asset so that it's ready to be handed over to animation. So I wanted to do first an introductory video on a few topics that I'm assuming you're probably already familiar with because this is an intermediate to advanced level course. If you are new to rigging or new to Modo, I strongly recommend you get Rich Hurry's rigging course. It's a course that covers all the basics very thoroughly. Rich does an amazing job at explaining everything in a way that is easy to understand and follow. So if you are new to rigging, I really recommend you start with those videos because there's a lot of stuff that we're going to be doing here that I will be assuming you already know. So that course is very good at taking you through the basics and some not so basic stuff too. And once you're done with those, or if you're already familiar with all the rigging tools that exist either in Modo or other software such as constraints, kinematics, and all that, then we will just take all that and start applying it to rigging a character in Modo. But I'm going to do a very quick overview of stuff you need to be aware of in Modo before we start actually rigging. And for that purpose, I created this scene called Introduction. So let's look at a few things. The first thing I want to go over is the environment, and let me go back to the way you will find it when you start the software and open the scene. And as you can see, we have over here a toolbar of stuff that we're going to be using a lot. We are in the setup tab, and this is where we're going to be spending most of our time rigging in the setup tab, actually all of our time. Here we have the tools that we're going to be using. This is our items list that we're going to be looking at a lot to manage the objects in the scene, the properties for the objects that we're going to be handling, and the schematic view, which we're going to be using a lot too. For now, I'm going to maximize my viewport. We're not going to look at the schematic. And let's look at some of the stuff that we have. In the setup tab, you will find that we also have a setup button, and this is a mode. Setup mode is extremely important in rigging. And what it does is anything that you create or modify while in setup mode is going to be assigned as the initial state of an object. And this is extremely important when talking about transforms and deformations, because the initial state of an object is the reference that Modo uses to know where the object was and what was its state before the animator or the user moved it somewhere else. And then it uses that difference between the initial state and the current state to determine if any objects that are depending on the object that changed are supposed to deform or change in any other way. So setup mode is very important. Whenever you are about to change an object or to create an object that you want to be based on the current state that has in the scene, do it in setup mode. Once you go out of setup mode, you can start moving around stuff, and anything that deforms is going to be deforming too, or that is supposed to change is going to be reacting to those changes that you perform. But you will see how we use setup mode throughout the course, and it's very important to be aware of when you need to be in setup mode so that you don't do anything that later is going to have very funny, in a not funny way, side effects on your project. But let's continue with the overview. So we have a setup tab too here in our toolbar, where you will find tools to do some basic operations. When it comes to rigging, we can create curves and skeletons, joints. that we'll use for rigging purposes. We can manage hierarchies and align objects. And then in the modifier tab, you will see that we can create and manage channels, which are the entities in the scene that handle animation. They can either store keyframes or drive or be driven by other channels. And we're going to be using the schematic view to manage a lot of that. Then we have constraints and dynamic parenting, which is a special case of a constraint. We'll see more of that later. Then we have the inverse kinematics tab with two types of IK solvers. We have a full body IK, maybe in your version of the software this is called something else. And then we have a 2D planar IK. We'll see the difference between both and how they work. The actors and sets tab, we're not really going to go into this one because this is more for animation workflows when you create actors and decide how you're going to animate those, and basically they handle how animatable entities are managed in the scene. Same thing for channel sets and stuff like that. We're not going to go over this. Then we have the deformers tab, which is very important. We have different types of deformers in Modo. We'll see how to use these. How to create deformers, which is the difference between normalized and non-normalized deformers. We're going to go over the deformation stack that we have in Modo for objects in something called order of operations with these deformers, which is very important. And we're also going to be using thoroughly and explaining weight containers, which is something that I believe makes Modo very powerful when it comes to creating rigs and deformations for these rigs. You'll see how this works throughout the course. And of course the weighting tools, because a lot of the deformers we'll be using will depend on weight maps to determine how they deform the object that they're supposed to. And these weight maps can have values that change in them, so we're going to be seeing how to weight deformers using these weight maps and the tools we have to change the weighting. And that's pretty much about it. That's what we're going to be using. This is an overview of the stuff that we are looking at. So in the next video, I'm going to be discussing some introductory concepts that you want to be aware of as we start rigging our first characters in Modo. So let's continue on that one. See you there. Okay, let's talk about some other concepts that we need to cover so that you are aware of some differences between Modo and maybe some other softwares, or just revise stuff that you're supposed to already know. So the first thing we're going to go over is centers and pivots and the difference between these. As you know, in Modo, an object has both a pivot and a center. And if you're coming from a different software application, what you know in other apps as a pivot point, in Modo is actually the center of the object, not the pivot. The pivot is something that is more used for animation purposes. We're gonna see about a little bit about that maybe later. And you can think of it as maybe an additional center that you have access to, and you can animate in space to change how the object is being transformed. But we're mostly going to be dealing with centers when it comes to rigging in Modo, and you have access to them by just clicking on the centers button, and then you will see that for whatever object you had selected in the scene, the center will appear over here, and you can select it and then manipulate it and move it around if you wish. So that's one thing I wanted to cover very quickly. We're not going to do anything with it right now, but we'll probably go into dealing with centers for a lot of the mesh objects that we're going to be rigging later. So let's go back to items mode, and here we have item selected. Let's talk a little bit about hierarchies. So hierarchies are very important, and this is something you should already be aware of and how they work, but I want to just go over them very quickly and revise what they are and how they are built. So a hierarchy is a family of objects that have a relationship between them that determines how they transform in space. And in this case, I have here this cabinet that has drawers on them, and I've selected the handle for one of these drawers, and you can see in our items list that our handle object is selected, and it has this arrow beside it. So if I shift click on it to expand the entire hierarchy, you will see that there's two more objects under the handle, and they also are being listed with indents on them, which means that they're not both parented under the handle, but there's also parenting in between them. So basically hierarchies, when it comes to hierarchies, we use two terms, parent and child, or children. And the upmost object is always the parent in a hierarchy, and then the objects under it are its children. So in this case, the handle has the cover object as its child, and this cover object, since it has another object under it, it's children. So the drawer is a child of the cover, but the handle is a parent for the cover object too. So that's the way we navigate hierarchies. They just go from top to bottom. And what they are used for is, hierarchies are very useful when dealing with transforms. And the reason is transforms are inherited on children objects from their parent, which means that any transform that you perform on a parent object, it's going to be inherited by all the children. And let's see that in action, see how that works. I'm going to select the handle and the move tool, and you can see that as I move the handle, the other objects are following. Now these objects are not selected, and I didn't do anything directly to them, but because I'm transforming the parent, this transform is being also inherited by the child's objects, and they follow. So this is very powerful when we're dealing with complex structures that we want to animate. You can do a very simple hierarchy all between your objects and then be able to drive animation or motion on a lot of them just by using a few parent objects. So this is very useful. In my case, for this file, I used it so that I would be able to move all the drawers just using the handle objects, and you can see that everything's been rigged. And I actually did different rigs depending on different examples that I wanted to show. As you can see in our previous hierarchy, we had a parent and another parent, and then lastly a child. But in this one, I have only one parent, and then both objects are parented underneath the handle. The reason is I figured that I would never actually want to move the cover by itself and have the actual drawer move with it. But what I did was I just said, okay, the handle is the one that's going to be moving, and I just want the other objects to follow. So that's how this other hierarchy works. So it's up to you to decide who needs to follow who, and then just create the hierarchy accordingly. And parenting and unparenting objects in Modo is very simple. I'm going to do that in a second. Actually, since we're talking about it, let's do that right now. I'm going to build another hierarchy using one of the drawers that actually has no hierarchy in it. Let's hide all the rest, and also hide the main. There's this handle, which I should have not. Where's the handle? Here's the handle. Let's actually drag this guy up here so that they're closer together. So we have an extra handle, an extra cover, and an extra drawer. There's several ways of creating a hierarchy in Modo, and the simplest one is you just use the items list to drag and drop objects in it. So let's take, for example, the drawer, and I can just drag and drop it under the handle, and it's going to be parented directly under it. I can also select both the drawer and the cover, and then drag and drop them under the handle, and they become children of the handle object. And now when I move it, they all move together. So that's a very basic way of creating a hierarchy in Modo. But sometimes your item list is very long and you don't have the objects nearby or close together to be able to do this. So you can also use tools to do it directly in the viewport. So all you have to do is first you select all the objects that are supposed to be that you're going to try to parent under something else. And lastly, you shift select the parent objects, so they're all selected. And then we go to the setup tab, and we hit the parent button. And as you can see, my two objects, the drawer and the cover, are parented under the last selected object, which was a handle. And now I have a hierarchy again that I can transform. When parenting, it's important to talk about there's two modes of parenting objects in Modo, and in most other 3D applications too. And one is like the standard normal parenting that we've done so far, and another one is what we call parent in place. When you drag and drop stuff in the item list, what you're doing is a parent in place. And I'm going to show you the difference between both. And to do that, let's create a couple of extra objects in the scene. I'm going to create a sphere. Let's move that around. Let's move it over here. And I'm going to create a cube. And let's also move this guy over there. So, good. So I have these two objects, and I want the sphere to be child of the cube. So I can just select the sphere, shift select the cube, and hit the parent button. And two things happened. One, effectively, the sphere is now under the cube. But the second thing that happened is the sphere moved. So why did it move? Let's talk about parent space for a second. I'm going to undo the parent operation. Let's go back and just take a look at our sphere. If we take a look at our sphere and we examine its transforms, you can have them here over the properties panel. We can see transform, position, rotation, and scale. You will see that the sphere has certain values stored in its position channels. So the sphere is at minus 1.86 meters in X and 1.05 meters in Z. But when you say I'm 1 meter away, that begs the question, okay, away from what? So you need a point of reference to exactly know where something is located in space. And the point of reference for an object is it's always its parent. In the case of objects that have no parent, for example, the sphere and the cube, its parent is the world. So empty space, the world, and how do we know how the world is used as a point of reference? Is using the grid. So we know that this point here, the grid intersection, is 0, 0, 0. So this is a point of reference that our sphere is using to determine where it is. So it's at minus 1.86 meters from the origin of the world, which is over here. So if we trace that on the x-axis, we'll go like right over here, which is minus 1.86, which is where the sphere is. Okay. However, when you parent stuff, and I hit the parent button, the sphere now is using a totally different point of reference because its parent changed. Now it has a parent. So from the point of view of the sphere, its new point of reference is the box, which means that the box center is its new 0, 0, 0. So when you do a parent operation, what Modo does is it always will keep the values that you had stored in its transforms intact, okay? But in order to do that, the object has to move to a new position, because if the sphere is to stay at minus 1.86 meters from its origin, and its new origin is here, then the sphere will move to retain these values, to have a constant distance to its point of origin, okay? So your values will be intact. However, there are times where you don't want that. You want to create a hierarchy, but have the objects retain their positions in space. So to do that, what you do is, let's go back to our original setup. You have to do a compensation, a parent in place operation using the compensation button over here. So what compensation does is it allows you to retain the transforms of objects that you are changing via hierarchies or constraints. So in this case, I select my sphere, I select my cube, and when compensation on, I go and hit the parent button, which as you can see has changed to parent in place. So when I do this, the sphere is parented to the cube, but it retains its position in space. However, what did change are the values for its transforms. And these had to change because, well, obviously, if it's new 0, 0, 0, it's over here, then the position and maybe even the orientation of the sphere in relation to this object is totally different one of what it had before with the world origin. So in this case, now on X, my sphere is at minus 3.69 meters from the cube's center. Okay, so you gotta be aware of how you parent stuff and what will happen when you do, depending on which mode you're in. You either have compensation off or on. So you do a normal parent or a parent in place. And we're going to be doing that a lot throughout the course. We're going to be doing standard parenting and parent in place. And I will be using also drop actions to do all my parenting when it's more convenient. So that's very important to know. The last thing I want to go over is something that I think it's very important, and this is not just for rigging, but for any part of the pipeline in a 3D production, and it's naming conventions. As you've seen, if you've examined the file that we've been working with, my objects have names on them that basically reflect what they do. Some of them don't, but that's because the assets that I took that are part of the material that ships with Modo were just named this way, and I didn't change them. But anything else that I created has a specific name on it, and I'm going to show you the naming convention that I use. I'm not necessarily saying you have to use mine, and I'm definitely not saying mine is the best. It's the one that works for me. You'll probably be able to find something that works better for you. Sometimes it's not even you who decides. If you work in a facility where there's more people involved and there's teams that do certain things, then it's the pipeline that decides how things are named, and you need to abide to these naming conventions. Otherwise, your assets are basically not going to go anywhere. But I definitely think that it's a good practice that you start using a naming convention for your stuff, for all of your work, from this point on, if you don't do it yet. As I said, if you already have a naming convention that works for you, by all means keep using it. You'll see me use mine, and I'll explain to you how I name things, so that you might decide if you like it or not. The way I do it is, first I write a little acronym, trying to use only 3 letters in uppercase that tell me what kind of object I'm dealing with. So in this case, this is a geometrical object, it's geometry, so I write geo. In the case of locators, for example, I could use LOC, and that depends also on the function of the locator. Sometimes they're controls, so I write CTL, or they are up vectors, so I write UPV. I'll give you a complete list of the acronyms I use for this later on, but in this case, this is geometry, so I write geo underscore. I always separate stuff with underscores. I don't use spaces in names because I use something called camel case, which is used a lot in programming, so there's no spaces in that. And most names start with a lowercase, and then when you separate words, you do it by using uppercase letters. So this is called geo. Then I write a letter that tells me on which side of the asset this is going to be. Most things need to be on a particular side. In the case of a character, you'll see that we're going to be rigging stuff that is either on the right side of it, or the left, or sometimes the front, or the top, or the bottom, or the top left, or the bottom right, stuff like that. So let's say that this sphere is supposed to be on the right side of the character. So I will just write an R, which for me is R. If it was the top right, would be TR for example. And then I give it an actual name. Let's say this is a cannonball. I will use camel case to write cannonball, right? And sometimes I have to use a suffix. Suffixes are useful for certain situations. I don't have one on hand right now, but I might use a suffix for it. And then lastly, if it's an object that is going to be repeated in the scene a few times, I number it. So you can use 001 or just 01 or whatever, and that's going to be my name. Okay? So that's the way I use names, and that's the way we're going to be using throughout the course. As I said, feel free to use your own convention, but please name stuff. Even in the schematic view, we're going to be renaming stuff when appropriate, because there is nothing more horrible in life than taking somebody else's file and opening it and seeing 300 locators named locator 01, locator 02, locator 03, all the way to locator 300. That will kill you. And in most production studios, your files are not going to go even through the pipeline with stuff named like that. So, yeah, naming conventions, very important. So that's that. And I'm going to leave this video up to here. In the next video, I'm going to cover very basic explanation of what kinematics are and how we're going to be using them throughout the course. And then we'll do a fourth video that is going to be part of this introduction into rigging. And then we're just going to jump right away into rigging our first character in Modo. So, brace yourselves. See you later. Let's talk a little bit about another subject that is important to remember, which is kinematics. And this basically refers to the way objects in a hierarchy will behave when transformed. You've probably already heard or even used the names forward kinematics and inverse kinematics. And basically what this is about is it's mostly about how transforms travel within a hierarchy of objects. So we've already seen that in hierarchies, when you transform a parent object, its children inherit those transforms. So this is what's known as forward kinematics, because the transforms are going forward down the hierarchy. And that's the simplest way of kinematics that we have. However, there are times where a forward kinematics chain is not ideal for animation. Let's take, for example, the case where you have a character that is supposed to walk down over here to the edge of the cabinet and then put his hand on it and turn around and to keep talking to another character that's facing in the other direction. So in that case, what happens is when your character comes over and leans on the cabinet, as you continue to animate other parts of the character, like let's say he has to bend his torso a little bit that way to look at the other character, then the hand would slide. And that's because doing any transformation on the torso will then propagate down the arm all the way to the last finger, and then you have a sliding arm. Same would go for walk cycles, for example. It would be very difficult to get a character to walk, because if the pelvis is moving, the legs are going to be following, and then it would be up to you to hand compensate for those transforms and then move the object, the children object, back to where it was before by rotating its parents, and it just becomes a big problem. So that's why inverse kinematics is used. So inverse kinematics is a way of transforming hierarchies that work the other way around. In this case, what you do is you transform children in the chain, in the hierarchy, and all the objects that are parent or up the chain from this object are going to be rotated by an IK solver. so that they maintain the hierarchy properly. And I have an example of that here. I'm not going to go deeply into inverse kinematics now. We're going to go into that later. But I want you to just do a quick overview how it works. So here, again, cabinet handle, it's the parent of the drawer. It's fine. Over here we have this lamp, which I already semi-rigged with IK, with inverse kinematics. So let's open up the lamp rig. You will see that a lot of the geometry is just parented to these locators, and you do not necessarily require joints to apply IK to them. IK can be applied to anything. In this case, I just used 3 locators, and that's pretty much it. So these 3 guys are in a hierarchy. They have to be in a hierarchy to be able to use IK. And then I have my IK goal over here, which is this guy, which is the one that will be driving how things are transformed when I move it. So you can see that if I grab it and I start moving it around, then the lamp follows through. And the nice thing about inverse kinematics is that these goals are independent from the actual IK chain. So that if I take, let's say, the root object of the rig and I move it, you can see that the goal does not move, and therefore I can actually anchor this part of the rig in space. So this, if this was the hand of the character, it would never move from here. Right now the head of the lamp is rotating because of how this is rigged. As I said, this is not really a great rig. It's just something that I use to show what IK does and when it's useful, but there's better ways of rigging this so that wouldn't happen. So that's pretty much it. I just want you to be aware of this because our character that we're going to rig is going to use both approaches. There are certain situations where FK, or forward kinematics, is a much better solution to a given animation problem, and there are others where IK is a much better solution. In some cases, we may even need both, so we'll see at how to create rigs that can blend between IK and FK transforms and use that in parts of the character where it makes sense. So this is pretty much it. In the next video, I'm going to cover a subject that is very important to be aware of when dealing with hierarchies of specifically joints. It's applicable to any hierarchy, but we're going to use it a lot with joints. So let's move on to the next video.